have 3 times 4. Then 3 times 2. Then we shall have 3 times 2. This and this. Then we shall have 3 times 4. So if you out this product, we have for 2a, we shall have 30, 18. This and this is 12. This and this is 6. Plus 3 by 4 is 12. 3 by 2 is 6. 3 by 2 is 6. 3 by 4 is 12. So these are the scalar multiples. Then now from the operational addition that we look at, that we add the corresponding elements. This is 2 by 2. This is 2 by 2. It has 2 rows and 2 columns. Matrix. The next one has 2 rows and also 2 columns. So we add the corresponding elements. We have 30 corresponds to 12. So that plus 12. Then 18 corresponds to the second one, it is 6. For 2, we have 12 plus 6. Then for the second term, 6 plus the second term, 12. So if you add this, then you get 30 plus 12, that is 42. 18 plus 6, that is 24. 12 plus 6, 18. 6 plus 12, 18. So the matrix that is twice A plus thrice B shall be 42, 24, 18, 10, 18. This is how the scalar multiplies the matrix. A is 59, 63. Twice A means it's twice 2 by matrix A. There is 3 by matrix B. So by this is the scalar multiple. So the scalar must multiply each and every element of the matrix. 3 must multiply each and every element of matrix B. So if you have this, then you get twice A starting 18, 12, 6. Thrice B gives us 12, 6, 6, 12. And therefore, adding the two because of the same order can give us 30 plus 12 with the corresponding elements. 12 plus 6, then 6 plus 12. In the same way, let us evaluate the following. Number 2, we're using matrix A and B. We get a matrix that's 2/3 A plus twice B. Then we can also get 3 times B plus twice A. Then we can do the final one. It is 1/3 A minus 4 times B. Let us evaluate using matrix A as given 59, 6, 3, B 4, 2, 2, 4. We evaluate 2/3 A plus 2B, 3B plus 2A, 1/3 A minus 4B. Then we shall share the result as we are doing. Let's get 2 minutes to do that. Huh? Why don't they copy that? They do that exercise first. Yeah. So let us work out. Matrix A is 5963. Matrix B is 4224. Let's give time to our colleagues to also work out and complete. Was. You have a bigger camera in the video room. Or kama hii. Okay. Wapi? Mute hapo. This on off. So are we through? Check and compare with the results that are on the screen. Check and compare. You can evaluate yourself.
So you know where you have gone wrong. Is it projecting mine? Okay. So let us look at the next operation. And the next operation is that of multiplication. Now, when it comes to matrix multiplication, this means that we are multiplying two matrices. So given two matrices of the same order, say matrix A and B, that the matrix product AB is the sum of products in the rows of A and in the columns of B. What does this mean? That the elements of the matrix A, those in the rows of A, shall multiply those in the columns of B. And the corresponding products obtained will therefore give us a single number that will be the product element of the product matrix AB. That for this therefore to be possible, it has to be known and understood that for the matrix product, we must therefore check that the order of each of the matrix is clearly defined. The rows in the first matrix must be equal to the columns in the second matrix for it to be possible. Because as we do this, the order of each matrix shall be determined first. And the number of columns in the first matrix A must equal to the number of rows in the matrix B for this to be possible. So this is normally the necessary and sufficient condition for any two matrices to be multiplied. For us to perform matrix multiplication, we must check for this necessary and sufficient condition before we proceed. Let us explain this further before we look at examples. That, check that. If we have two matrices, A defined as A, B, C, D. Then matrix B defined as E, F, G, H. This is 2 by 2 matrix. And this is also 2 by 2. That for us to check if this is correct and we can perform multiplication, then we look at the columns of A and the rows of B. That these two must be equal for us to perform the matrix product. Because we are going to get the sum in the elements of the rows of A and those in the rows of B. How does this work? That the matrix product AB will be given by the product of A, B, C, D times that of B, E, F, G, H. Now let us be very careful that we are going to use the first row, the first column. First row, the first column. Row 1 multiplies from 1 to B, so that we have A times E plus B times G. The rows of A are multiplying the columns of B. Then, for the second column, A times F plus B times H. It is the first with the first, the second with the second, first with the first, the second with the second.
Similarly, repeat the process for row 2. For row 2, I want you to understand that these elements are multiply this element. That the first element C will multiply the first element in the first column. The second element B shall multiply multiplication. The second element G. Then we do the same for second row, second column. Then the first element C shall multiply the first element F. Plus into the sum product in the rows of A and the column of B. Then D, the second element, must multiply the second element. B times H. So this will be used to the sum of AE plus BG, AF plus BH, PE plus PG, CF plus PH. This is what will give us the matrix product AP. So we can multiply as long as what we have conforms that the column of A must equal to the column of B, which is the second matrix. If that's possible, then the necessary sufficient condition is met. So let us see this in the following examples.
We get an example from the past paper. You get this part. Now, suppose we have the following. Matrix A defined as 3, 7, negative 4, 2. And matrix B defined as 6, 8, 3, negative 3. So the matrix product that we need is AB. This is 2 by 2, this is 2 by 2. So they are compatible. So we shall have A 3, 7, negative 4, 2 by 6, 8, 3, negative 3. So if we multiply through the first row, we want to see to it that we have the first row with the first column. So we shall have 3 by 6 plus 7 by 3. 3 by 6, 7 by 3. Then first row, second column. We shall have 3 by 8 plus 7 by negative 3. Then we do the same for the second row. For the second row, we have this. With this, so second row, first column is negative 4 by 6 plus the next element is 2 by 3. Then second row, second column, negative 4 by 8 plus 2 by negative 3, which gives us 3 by 6 is 18 plus 7 by 3, 21. 3 by 8 is 24 plus 7 by -3, -21. -4 by 6 is -24 plus 2 by 3 is 6. -4 by 8 is -32 plus 2 by -3 is -6. Evaluating this, we have 18 plus 29, 21, that gives us 39. 24 plus -21, that gives us 3. -24 plus 16, plus 6, that will give us -18. -32 plus -6, that will give us -38. So the matrix product in this case, arising from matrix A and B, gives us the matrix product as 39, 3, -18, -38. So the key thing is first check for compatibility. Are the number of rows in A equal to the number of columns in B? Then proceed to get the sum of products in the rows of A and columns of B. Those sum of products will give you the product matrix A, B. Let us see other examples from our screen. So suppose we have a matrix A as 42, 6. Then 6, 12. And B as -2, 8, 7, 6. Let us get the matrix product AB. Get the matrix product AB. Niwaandikie hapo kwa ubao. Let us get those matrix products for number 1, 2, 3, and 4, following the same approach that we used to get AB in our example. Let us get the answers, then we see what we have, if we are correct or not. Acha hiyo baki tu kwa ubao hiyo. So get the matrix products of the matrices indicated for number 1, 2, 3, and 4. Let us work out and see for the 4. Ndio kimaliza. Are we through? I'm not seeing anything on the chat box. Walipotea ama wapi? I'm not seeing anything on the chat box. Yeah, very busy working. Negative 11, negative 5, negative 6, negative 15. People busy working. Only that invested us at the beginning. Number 3. Could be number 2. Number 3. 3, 10, 12. Number B. Number 1, 39, 3, 18. Sio tulifanya. Ndio nimeingia. Mnafanya nini wasema? We are now okay. They are now okay. Oh, wanataka nikiendaenda kwa ubao. Umegundua hivyo, wanafurahia nikiwa kwa it is not working because they are not of the same order. Number C is P with the elements 4, 5, 6. And S with the elements column matrix 100, 200, 200. Some students are jokers. Do for us. Tangoja sasa hapa lazima utakuja consultation. Unajua statistics hakuna mtu alikuja. Hakuna. Sasa hapa lazima utakuja. In fact, I'm doing it intentionally. Yes. I'm doing it intentionally so that they ask. They come. I'm done. Number 6. Si ndio gani sasa? Fanya question 3. Just do number 3, sir. Number 3. We shall come, sir. Wacha zako mzito bwana. Kwani unafanya tu kijua. Wananisikia? Wananisikia? Hii kitu iko microphone. Hii ya mfuko hii. Na mtu hapa anasema bwana, kumbe utafanya tu kijua. Atuye dunia tufurike kwako kahono kako ofisi. Okay. Check. For number 2, you should have 27, 2, 6, 13, 401. Row 2, 28, 8, 54, 12, 68, 8, 79, 32. Check. This one was 300. Yeah, this one I used to 300. Check. 1, 0, 2, 4, 5, 8. Screen inaonekana. Good, you can work out that later. Let us now look at the last concept, then we wind up. We wish to look at what we call the determinant of a matrix. And when we talk about determinant, this is nothing other than a scalar that is obtained from the product difference in the matrix, those of the main diagonal and those of the other diagonal, if it is for a 2 by 2 matrix. That can go there now. Let me copy this first. That copy here as examples. 34, 15, 2, 8, 7, 6, 3, 2, 4. So ladies and gentlemen, we want to wind up by looking at the determinant. When you look at the determinant, we are looking at the modulus or otherwise the distance, the absolute value. That absolute value will give us a scalar. And the scalar as we define, this might be a whole number, a fraction, a positive number, or a negative number. That whichever rational number plus the set of irrational numbers, that is what will give us
the scalar. So what are we saying about the determinant? That this is the distance between the two.
When you are given a matrix A, defined as A, B, C, D, this is for 2 by 2. Then the determinant of A, which we denote as det A, or they'll give you A between those two bars. This is the difference between the elements in the main diagonal and those in the other diagonal. Let us see what are these elements in the main diagonal. That we saw that in matrix A, the elements AB form row 1, the elements CD form row 2, the elements AC form column 1, the element BD form column 2. But we can also define this, if you recall how we define the diagonal matrix. We can define this in terms of diagonals. That in any matrix, we can see the diagonals, one running from the top left to the bottom right. And then the other one I'm giving in black. So that which runs from the top left to bottom right, this is what we are referring to as the main, or otherwise the primary diagonal. And this that runs from top right to bottom left, this is what we are referring to as the secondary, or some books talk of the other diagonal. So when we get the difference in the products of those diagonals, what we get is what we are referring to as a scalar quantity that is the determinant. So for our matrix A, defined as A, B, C, D, then the determinant of that matrix will be the difference in the products. Those in the main diagonal, A times D, minus those elements in the other diagonal, B times C. So this in essence gives us the product AD minus BC, and this is a scalar. This will give us a scalar. Look at the matrices given. I choose matrix B. Example, matrix B, defined as -2, 8, 7, 8. The determinant of B will be given by the product of the elements in the main diagonal. This is our main diagonal, which gives us -2 times 8 minus that of the other diagonal. The one I'm indicating in black is the other diagonal, which is 8 by 7. So this will give us -16 minus 8 by 7 is 56. And therefore, -16 minus -56, that will give you 2. That is 6, 7, -72 as the determinant. So -72 is the determinant. Look at other cases. Like a matrix given as matrix M, defined as 3, 2, 2, 4. Then the determinant of M is defined to be the matrix product difference 3 by 4 minus those in the other diagonal 2 by 2. And this will give you 12 minus 4. And that will give you 8 as the determinant. So the determinant is always a scalar. It gives you a single value. Maybe you look at the final case. A matrix D defined as 3, 4, 1, 5. Then the determinant of D, if I do it this way or this way, is the same, the determinant. This would be the product of the elements in the main diagonal, that is 3 by 5. Minus those in the other diagonal, 4 by 1. So this will give you 15 minus 4, and that will be equal to 11. And that, I think, is easier. Find the following determinants. Then we compare what we have. Matrix A defined as 3, 4, 1, 3, 4, 1, 5, we have done it. Negative 2, 8, we have done it. 3, 2, 2, 4, we have done it. So we can look at 6, 1, 2, 3. That's 1, 2. We can look at matrix B, 46, 6, 6, 12. Matrix C, 15, 9, 6, 3. And we can have the last one, matrix X, 4, 2, 2, 4. Let us find out those, and then we share on our chat box. Evaluate those determinants, and let us share on the chat box. In rice. So do for 1, 2, 3, and 4. Then share. We are looking at 2 by 2. So the difference should not be a problem. 2 rows and 2 columns. Wanachapa kama umeme. So I see most of you are through. Most of you are through and you are getting it correct. So I think it's becoming easy on that. But where the problem was multiplication. It gave you real problems. Hiyo ni sawa. I can read your chat. So is my screen on? But talking in general, we are looking at this, that we can identify the element in terms of its row and column. But if I have a matrix A, where the first element is A11, meaning it's row 1, column 1. The second element in row 1 is A12. So this is element A in row 1, column 2. Then in terms of row 2, I have A21. This is an element in row 2, column 1. Then I have A22, an element in row 2, column 2. Then the determinant is the difference. A11 times A22 minus A12 times A21. That is the general way of getting the determinant of a 2 by 2 matrix. You have looked at this and you can find what it is. So you have found it correctly. So next time, we would wish to start from the determinant for 3 by 3 matrices, whereby 3 by 3 matrices are matrices of order 3. They have 3 rows and 3 columns. Basically, what we shall learn is how do we reduce this from 3 by 3 to 2 by 2, so that we can evaluate, because we know how to find the determinant of a 2 by 2 matrix. So we wish that we start from there. Next week, we pray that we shall not have power interruptions that will cause and affect the internet connectivity next week. Thank you, and we wish to adjourn. Unless there are questions, please, if there are questions, put them on the chat box. If there are questions, put them on the chat box. YouTube link. Now, as we do this, if God willing we conclude matrix algebra, we need to be planning as to when we should have the cut. Can I request the class reps to consult so that next week you tell me when you will be comfortable to the cut 1? I hope that is to everyone. Thank you so much. Let us adjourn and meet next week. Keep time. I have noted some of you come late. Thank you. You can now unmute and beat your own stories. Wamekimya.
Malau.
We mtu mmoja mmoja.
Wewe nyamaza.
Tila alma tuko na data.
Kana karibu apigwe alipona.
Hebu nisikize kwanza ni